Welcome back to the CCNA Cisco NetAcad Introduction to Networks lecture series. If you are interested in the previous lectures, I will leave a link in the description to the playlist and you can use that to watch them. Today, we will be focusing on Module 15, which is the application layer. In this lecture, we will learn the operation of application layer protocols in providing support to end-user applications. We will cover the application, presentation, and session layers with respect to OSI model, and the TCP model will be covering that with the application layer section on their side. We will learn about peer-to-peer communication. We will learn about web and email protocols and explain how those protocols are used. We will learn about IP addressing services, and we will cover file sharing services. Application, presentation, and session. Application layer. The upper three layers of the OSI model includes application, presentation, and session, define functions of the TCP/IP application layer. So if you look at the right hand side of this window, you have the TCP/IP model on the right and the OSI model on the left. And on the TCP/IP model, the application layer, which sits on top of the transport layer, covers the application, presentation, and session layers, which sits on top of the transport layer on the OSI model. The application layer provides the interface between the applications used to communicate and the underlying network over which messages are transmitted. Some of the most widely known application layer protocols include HTTP, FTP, TFTP, IMAP, and DNS. The secure layers, which are like HTTPS, is also part of the application layer, which is basically a secure version of this HTTP, for example. Presentation and session layer. So the presentation layer in the OSI model, which is still part of the application layer on TCP/IP model, has three primary functions. They are formatting or presenting data at the source device into a compatible format for received by the destination device, compressing data in a way that can be decompressed by the destination device, encrypting data for transmission, and decrypting data upon receipt. For the session layer functions, what it does is it creates and maintains dialogue between source and destination applications. It handles the exchange of information to initiate dialogues, keep them active, and to restart sessions that are disrupted or idle for a long period of time. So in presentation layer and the session layer, these are the key important things that is being addressed in the OSI model. Remember, these are still part of the application layer on the TCP/IP model. TCP/IP application layer protocols. The TCP/IP application protocols specify the format and control information necessary for many common internet communication functions. Application layer protocols are used by both the source and destination devices during a communication session. For the communications to be successful, the application layer protocols that are implemented on the source and destination host must be compatible. So that's a very key important concept that you should get out of this course. For the communication to be successful, the application layer protocols that are implemented on the source and the destination has to be compatible with each other. If the source and destination have incompatible application layer protocols, the communication between the two will not occur properly. Some of the examples of the TCP/IP application layer protocols would be DNS, DSCP, and HTTP. The DNS is a name system that use TCP UDP client in port 53, and it translates domain names such as cisco.com or sanuja.com into an IP address. DHCP is the dynamic host configuration protocol, which use the UDP port 68 for the client and port 67 for the server, and it dynamically assign IP addresses to be reused when no longer in need. And also it also provide IP addresses for new devices when it connect to a network and it requests that IP address information. HTTP is the hypertext transfer protocol, which use the TCP port 80 and port 8080, and it sets a rules for exchanging text, graphic images, sound videos, and other multimedia files on the World Wide Web. We will go in little bit detail. We'll look into little bit detail on DNS, DHCP, and HTTP in this course as we move through the lecture series. For now, just remember these are some of the examples of TCP IP application layer protocols. Peer-to-peer. Client-server model. Client and server processes are considered to be in the application layer. In the client/server model or client-server model, the device requesting the information is called a client and the device responding to the request is called a server. Application layer protocols describe the format of the request and responses between clients and servers. So in this example, for example, we have a server in here and we have a device, an end device, and it is requesting to download a specific file, let's say a video or an image file. And if it is directly communicating with this server, that is considered as a client-server model, where it's basically like a peer-to-peer type of communication, similar to that. Except the difference here is that it is not peer-to-peer because it's going through a network and a server is responding to a request by the end device. So peer-to-peer networks is also known as P2P network, have two or more computers that are connected via a network and can share resources such as printers and files without having a dedicated server. So in the previous model, we had a server, right? So if you look at the previous model, we have a dedicated server that is doing these the role of server to end clients. So we have 1, 2, 3 clients, and all of these 3 clients are connecting to this server to request information. But in the peer-to-peer networks, what happens is the 2 or more computers or end devices or devices are connected to each other, and they are communicating and sharing resources without having a dedicated server. So that's what make it a peer-to-peer networks. Every connected end device known as a peer can function as both a server and a client. That is a key feature of a peer-to-peer network. Every connected end device known as a peer can function as both a server and a client. One computer might assume the role of server for one transaction while at the same time serving as a client for another. So the same computer, so this peer can also act as in here we have a peer 1, can act as a client and the server at the same time. The roles of client and server are set on peer request basis. So that's what make it the peer-to-peer networks. Next, we will look at the peer-to-peer applications. A peer-to-peer or P2P application allows a device to act as both a client and a server within the same communication. Some peer-to-peer applications use a hybrid system where each peer accesses an index server to get the location of the resources stored on another peer. If you have ever used programs like BitTorrent or torrent applications, they are actually the peer-to-peer applications. They use this type of technology. And that is what it is shown here on the diagram here. So basically you have a client and a server and a client and a server. So there is no dedicated server just a client. Client also act like a server also act like a client, right? So we have an instant messaging platform in here for an example. So it's just sending back and forth between send and receiving data. And each time when they send the data, this is acting like a client type of thing, and then it is like a server type of thing, and when it's receiving data, it's like acting like a client type of thing, and it's switching back and forth and doing that at the same time. So that's what make it a P2P network. So common peer-to-peer applications, as I mentioned, BitTorrent is one of them. So with peer-to-peer application, each computer in the network that is running the application can act as a client or a server for the other computers in the network that are also running that application. So the other common applications other than Torrent is the Direct Connect, eDonkey, and Freenet. They are all peer-to-peer network. For this class, what you need to understand is not these clients, per se. You don't actually need to memorize these clients. What you need to understand is the processes and the functions of peer-to-peer applications and peer-to-peer networks, like how they actually works. So basically, the key thing you need to get out of this is that in peer-to-peer networks, the same device can act like a server as well as the client at the same time or at different instances, as opposed to having a dedicated server. Web and email protocols. Hypertext Transfer Protocol and Hypertext Markup Language. When a web address or Uniform Resource Locator, also known as URL, is typed into the web browser, the web browser establishes a connection to the web service. The web service is running on the server that is using the HTTP or Hypertext Transfer Protocol. To better understand how the web browser and web server interact, let's examine how a web page is opened in a browser. In this example, we are using the website www.cisco.com. So on the web browser, the browser interprets three parts of the URL or Universal Resource Locator. The HTTP part, which define the protocol or the scheme. www.cisco.com part, which is the server name. And index.html part, which is the specific file name requested. So you have a server and you have a client. So the client is requesting that cisco.com web page, and the web browser is interpreting those information in order to reach this web server. So in step 2, what happens is the browser then checks with a name server, which is a DNS, to convert www.cisco.com into a numeric IP address, which it uses to connect to the server. Remember, servers and end clients and intermediary devices have IP addresses. They don't actually have the domain name itself, right? So that's why we had to use a DNS to figure out what the IP address is. The client initiates an HTTP request to a server by sending a GET request to the server and asks for the index.html file. So sometimes it is index.html, sometimes it's default.html. It can be configured on the server side as well. I will not go into depth of that, but I will do a separate course that I'm going to create on basic web systems, and I will explain that in that course. But for now, what you need to understand is the GET request is sent by the client, and then that's what causing it to receive that index.html file. Then on step 3, in response to the request, the server sends the HTML code for the web page to the browser. And that code also includes any resources that needed to be available on the client side to view, such as locations of images and videos, etc., etc. And the HTML code is similar to look like this. And if you would like to look at an HTML code, you can simply view the source code of this YouTube page, for example. Or you can go to sanuja.com or something like that. Just view the source code. That is pretty much the HTML code for that web browser. And in the step 4, what happened is the browser receive that HTML code and it decipher and format the page for the browser window. So like for example, just like the Cisco website, if you visit www.sanuja.com website, you will be presented with a page like similar to this. What you are seeing here is basically what your web browser has deciphered from the HTML code that includes all the code information on where these elements should be, like such as these images, these texts, these links, and there are any information pretend into that. Like for example, when you visit sanuja.com, your web browser will decipher from the HTML code it received from my web server where this image is located, so that you will be presented with a proper web page. Next, we're going to look at the HTTP and HTTPS. HTTP is a request response protocol that specifies the message type used for that communication. Those 3 common message types are GET, POST, and PUT. GET is a client request for the data. A client or the web browser send a GET request message to the web server to request that HTML pages. POST, this uploads data files to the web server, such as form data. So if you go to my website and you fill out my contact form, for example, and when you press submit, that is using that POST request, the POST message. And then PUT, this uploads resources or content to the web server, such as an image. So if you attach an image, for example, for that message, and you send it to my web server, that will be using both POST and PUT messages to achieve what needed to be achieved on the server side. Note, HTTP is not a secure protocol. For secure communication sent across internet should use HTTPS. And if you go to my website sanuja.com right now in 2022, for the past couple of years, like I believe last 5 years, I have been using HTTPS sanuja.com. But prior to 5 years ago, I have been using HTTP sanuja.com, which is not a secure protocol. So what you need to understand with respect to HTTP and HTTPS is that we use the get, post, and put request on both HTTP and HTTPS requests. Email protocols. Email is a store and forward method of sending, storing, and retrieving electronic messages across a network. Email messages are stored in databases on mail servers. Email clients communicate with mail servers to send and receive emails. So as opposed to the HTTP and HTTPS protocol, which is a request and response protocol, what you need to remember is email is a store and forward type of protocol. And the email protocols used for operations such as SMTP, which is a simple mail transfer protocol, and POP, which is Post Office Protocol, and IMAP. So the SMTP is used to send emails or mail, And post office protocol or POP and IMAP is used for clients to receive that mail. So the sender will be using SMTP and the receiver will be using POP to receive it. In this example, the sender is sending an email to someone at cisco.com, and it goes through using the SMTP protocol across maybe multiple servers and multiple routers and switches on the internet, and it reached the recipient, but the recipient will be using the IMAP or POP3 to receive that data. So the sender is sending using the SMTP, while the recipient is using IMAP or POP3 to retrieve that email. SMTP, POP, and IMAP. When a client sends email, the client SMTP process connects with the server SMTP process on well-known port number 25. So the port number 25 is a standard well-known port for SMTP process. After the connection is made, the client attempts to send email to the server across the connection. When the server receives the message, it either places the message in a local account if the recipient is local, or forward that message to another server for delivery. The destination email server may not be online or may be busy. If so, SMTP spools messages to be sent at a later time. Note: SMTP message formats require a message header. Recipient email address, sender email address is included in that message header, and a message body which includes the data that the sender is trying to send to the recipient. And one of the key things that you get out of this is that because SMTP, POP, and IMAP is an email service, if the destination email server is not online or busy, it has the ability, the SMTP protocol has the ability to spool messages that to be sent later. So the message, when the sender sends the message, it doesn't need to reach the recipient right away. If the recipient server or the recipient clients are busy, it can spool those messages and send it later. And another key piece of information you get out of this slide is that the SMTP message formats require a header that has the recipient email address and a sender email address, just like we look at those packets with the header having sender and receiving MAC addresses or sender and receiving IP addresses. So in packet switching and network communication, most of the formats we use, most of the protocols we use must have the sender and the receiver information. So the POP is used by an application to retrieve mail from a mail server. When mail is downloaded from the server to the client using POP, the messages are then deleted on the server. The server starts the POP service by passively listening on TCP port 110 for client connection request. When a client wants to make use of the service, it sends a request to establish a TCP connection with the server. When the connection is established, the POP server sends a greeting. The client and POP server then exchange commands and responses until the connection is closed or aborted. Remember, TCP connections are reliable connections. We learned about that in our previous modules, and if you would like to look at the TCP and UDP in depth, please go and check my previous module, and you will learn about that in that particular module. Note: POP does not store messages. It is not recommended for small businesses that need a centralized backup solution to use POP service. So one of the problem with the POP service is when the message is sent to the recipient, the message get deleted from the server. So that is not recommended for most business and company usage, because if you would want to back up all your emails or the recipient delete the emails on their end that may not be able to retrieve back from the server. IMAP is another protocol that describes a method to retrieve email messages. Unlike POP, when a user connects to an IMAP server, copies of these messages are downloaded to the client application. The original messages are kept on the server until manually deleted. When a user decides to delete a message, the server synchronizes that action and deletes the message from the server. So an advantage of having an IMAP over a POP is that when the recipient retrieve the data from the server doesn't automatically delete that email. That data is kept, that email is kept on the IMAP server until the recipient decided to go ahead and manually delete it from the server. An example of one of the most common IMAP usage is that if you are using Gmail accounts for the past couple of years to a decade, the Gmail usually keep a copy of your email even if you are using a desktop client such as an Outlook, for example. So you can use Microsoft Outlook to access your Gmail account, but even though all the emails are downloaded onto your computer, desktop computer mail client, you still have access to the copies of those emails that you have received and sent on the Gmail servers. So you still can be traveling across the world and you still can access to Gmail web client and you will see the same messages because IMAP servers do not delete the copy of the message that has been retrieved by your client desktop computer. This is a key piece of information that will show up on your Cisco NetAcad CCNA and CCNP exams, and make sure that you know that key piece of difference between the POP and IMAP protocols. IP addressing services. Domain name service or DNS. Domain names were created to convert the numeric IP addresses into a simple, recognizable name. Because people like you and I can remember names and letters than what we can do with numbers, such as 192.168.155.3, for example. So that's why the domain name services are important. So fully qualified domain names, also known as FQDNs, includes things like Cisco.com or Sanuja.com. And they are much easier to remember for you and I, as opposed to remembering that IP address. The domain name server or DNS protocol defines an automated service that matches resources names with the required numeric network address. It includes format for query responses and data. So that's the primary role of a DNS protocol. And I will go over what a DNS message format look like on our next slide. But in this slide, what you need to remember is that the primary reason why we have FQDNs and DNS is because humans can remember Cisco.com or Sanuja.com as opposed to remembering the IP addresses associated with these websites. So on a DNS message, the DNS server stores different types of resource records that are used to resolve names. These records contain the name, address, and type of record. And in the DNS message format, there are few types of data or record types included within it. And they are, for example, A, NS, COD A, and MX records. A is an end device IP address. NS is an authoritative name server information, and COD A is a end device IPv6 address, and MX is a mail exchange record. So if you have an email information associated with that particular server or domain name, that's where the MX records come into play. When a client makes a query, the server DNS process first looks at its own records to resolve the name. So if it finds the name within its own process, within its own server, it would be able to resolve that request. If it is unable to resolve the name by using its stored records, it contacts other servers to resolve the name. After a match is found and returned to the original requesting server, the server temporarily stores the numbered address in the event that the same name is requested again. So when you first reach a DNS server, and if that DNS server has no information about, for example, sanuja.com, what it's going to do, it's going to go and look for other DNS servers that may have that information. And it's going to retrieve that information and then respond to you with the sanuja.com webpage and associated IP protocols and all the other protocols and data, because now it has learned where the sanuja.com server is located in terms of its IP address from the other servers. But now this DNS server that you reach learn about sanuja.com because of your request. It typically, the server will store that information and the IP address on its DNS, the DNS records. I will go over this in little bit detail as we go through this lecture. DNS uses the same message format between servers, consisting of a question, answer authority, and additional information for all types of client queries and server responses, error messages, and transfer of resource record information. So remember that the DNS uses the same message format between server, consists of a question, answer authority, and additional information for all types of client queries and server responses. That includes error messages, transfer of resources, and the resource record information. So in this table, we have a DNS message section and a description of what it's doing. So we have a question, something like the question for the name server. Then we have answer, which is a resource records answering the question. And then we have authority, which is a resource records pointing towards an authority. And then we have an additional section where resource records holding additional information within that additional section. So if you look at the DNS hierarchy, DNS uses a hierarchical system to create a database to provide name resolution. Each DNS server maintains a specific database file and is only responsible for managing name to IP mappings for that small portion of the entire DNS structure. When a DNS server receives a request for a name translation that is not within its DNS zone, the DNS server forwards the request to another DNS server within the proper zone for translation. An example of this would be the .com domain, .org domain, .au or .ca domains for Canada. Those are top level domains. So when a DNS server receives a request for a name translation that is not within its DNS zone, let's say I am in Canada and I'm trying to access .au domain, it can forward the request to another DNS server that may be holding complete records of .au or .ca domains and then retrieve that data for me. So we have something called root level domain, and that root level domain are other top level domains located in here in the root level. And we have the top level domains known as the TLDs. They include .net, .edu, .com, .au, .co, etc. And underneath it, let's say we have sanuja.com or cisco.com, it's going to become the second level domain, and that may include something like cisco.com, ftp.cisco.com, mail.cisco.com, and these are like web, FTP and mail. You can like further divide out like with the subdomain. And what you need to understand in this particular site is there is a DNS hierarchy, and we have root level domain and top level domain. And if the request for a website with the DNS records is not found within that DNS server or that DNS server zone, what's going to happen is the DNS server will forward that request to another DNS server within the proper zone for that translation. The NSLOOKUP command. NSLOOKUP is a computer operating system utility that allows a user to manually query the DNS servers configured on the device to resolve a given host name. This utility can be used to troubleshoot name resolution issues and to verify the current status of the name servers. When the NSLOOKUP command is issued, the default DNS server configured for your host is displayed. The name of a host or domain can be entered at the NSLOOKUP prompt. So if you look at on your top right hand side, in this example, they use the NSLOOKUP to look for DNS dash, it will give out the DNS-js.cisco.com, and it will give you that NSLOOKUP DNS server information. And when it go and look for this www.cisco.com, which is basically a name of a host or domain that we are entering here, the user is entering here, it will return the server information and associated IP addresses with respect to that server information as well. But however, look, the NSLOOKUP for a domain may also show DNS request timeout messages, which is not shown here. The NSLOOKUP here on the bottom right hand corner is showing exactly that timeout messages. These timeout messages doesn't mean that the website cannot be reached, because that may be because your request is trying to reach that DNS, and it taking a little bit of time to get that information back. In this example, what I have done is I log into my computer and look for and enter the NSLOOKUP command, and it returns back with the information for my default server. In this case, I have a DNS server that is Manuja.net, and the IP address associated with that is 192.168.1.1. And I look for the remote website, the website that is not located within my building, within my internal network, called sanuja.com, and it went and looked for sanuja.com records on Manuja.net DNS server. And what happened in this situation is it returned timeout messages, because they are still looking for it. It goes to the next DNS and is waiting for authoritative answer. Finally, they get a non-authoritative answer right here. And finally, it found the sanuja.com IP address, which is 192.185.255.33, because it's finally found that information on a DNS record. So that's one of the things that is not included in the original slide of Cisco. I included because I think it is important for your exams. It does show up. So NSLOOKUP may return timeout messages. Dynamic Host Configuration Protocol, or DHCP. The Dynamic Host Configuration Protocol for IPv4 service automates the assignment of IPv4 addresses, subnet mask, gateways, and other IPv4 networking parameters. DHCP is considered dynamic addressing compared to static addressing. Static addressing is manually entered IP address information. So what makes it dynamic is that if you have a device, especially cell phones and mobile devices, it can just connect it to your Wi-Fi network after entering the proper credentials, and it will automatically receive a DHCP IP address because it is dynamically assigned, and the user doesn't have to configure any static IP addresses or a gateway, default gateway, subnet mask, and etc. etc. When a host connects to a network, the DHCP server is contacted and the address is requested. The DHCP server chooses an address from a configured range of addresses called a pool and assign or lease it to the host. Many networks use both DHCP and static addressing. DHCP is used for general purpose hosts such as the end user devices, while the static addressing is used for network devices such as gateway routers, switches, servers, and printers. So if you have a corporate network or home network and you have a printer, network printer, or a file server, I would recommend that you use static IP addresses because you do not want those server IP addresses such as FTP clients IP addresses to change all the time, because that is something that is being always accessed by multiple clients, multiple end users, and it will always be connected to your network. It's not like a mobile device that keep connecting and disconnecting whenever if the mobile device is within your network connection area or not, right? But however, having that DHCP pool of IP addresses allow you to connect your cell phones, laptop computers, new devices when your friends arrive at your home and connect it to either your Wi-Fi network or through a wired connection. Your DHCP pool will automatically assign all the information it needs, the subnet mask, the IP address, the DHCP and DNS configurations, and everything will be assigned through that DHCP server. So that's why you might use both DHCP and static addresses even at home. And note, DHCP for IPv6 is known as DHCP v6, provides similar services for IPv6 clients. However, the DHCP version 6 does not provide a default gateway address. This can only be obtained dynamically from the router advertisement messages, and they are known as the RA messages. And we actually went through some of those IPv6 message overviews on our previous lectures. If you are interested in learning about the DHCP version 6 overview, you can go ahead and check my previous discussions, the previous lectures associated with this lecture series. You should know basic concepts associated with that for exams and quizzes for CCNA and CCNP exams. DHCP operation. This is an important concept that you should understand and you should remember like back of your hand for your exams. So when an IPv4 DHCP configured device boots up or connects to the network, the client broadcasts a DHCP discover message to identify any available DHCP servers on the network. So that message sometimes is called DHCP discover message, and a DHCP server replies with a DHCP offer message, which is known as a DHCP offer message or DHCP offer, which offered a lease to the client. So when you first boot up or connect to a IPv4 DHCP configured device, it send a DHCP discover message, and the DHCP server reply with the DHCP offer message. The client send a DHCP request, which is a DHCP request message that identify the explicit server and lease offer that the client is accepting. So they're saying, hey, I'm accepting that offer. Then the server returns a DHCP acknowledgement message known as a DHCP ARC message that acknowledges to the client that the lease has been finalized. If the offer is no longer valid, then the selected server responds with a DHCP negative acknowledgement known as a DHCP NAK message or NAK message. And the process must begin with a new DHCP discover message which started at the beginning up here. And on the right hand side, on this diagram, that is what the Cisco is trying to explain here. So you have a client that just got booted up or just connected to this new network, and he sent a DHCP discover message, and the DHCP server, whichever the DHCP server available in that network, or the DHCP server that the first DHCP server that received that information, gonna respond back with the DHCP offer message. And then the client sent a message back saying the DHCP request that identify the server and the list offer information. And then the DHCP server come back with the DHCP ARC message, which is an acknowledgement of that this client will be using that particular the IP addresses and information retrieved from that DHCP server. Note, DHCP version 6 has a set of messages that is similar to those for DHCP version 4. The DHCP version 6 messages are solicit, advertise, information request and reply, as opposed to DHCP discover, DHCP offer, DHCP request and DHCP ARC messages on the IPv4 side of DHCP. So those are like the differences. For these exams and quizzes for CCNA and CCNP, you should know the differences between the IPv4 DHCP messages and IPv6 DHCP messages. However, in this lecture series, we usually cover IPv4 more than IPv6. There's a lab available to you on your Cisco NetAcad site. If you have access to it, please go ahead and do the lab called Observe DNS Resolution. If you do not have access to this particular lab, I will try to find a copy of that lab and post to my website so that you can go ahead and do them. I would post this video and do this lab if you do have access to this lab. File sharing services. File Transfer Protocol, or FTP, was developed to allow for data transfers between a client and server. An FTP client is an application which runs on a computer that being used to push and pull data from an FTP server. So the client is a piece of application or a software that has to run on the end device in client side, that it can be used to push and pull data from the FTP server. In other words, save data or retrieve data from the server. So how this protocol works is, in step 1, the client establishes the first connection to the server for the control traffic using TCP port number 21. Again, remember the differences between TCP and UDP protocols from our previous lectures. And if you don't remember that, you should go ahead and check that on my YouTube channel. It's in the same lecture series. So FTP uses the TCP, which is a reliable connection, and it uses port number 21. The traffic consists of client commands and server replies. In steps 2, the client establishes the second connection to the server for the actual data transfer using the TCP port number 20. This connection is created every time there is data to be transferred. In step 3, the data transfer can happen in either direction. The client can download, which is pulling data from the server, or the client can upload, which is the pushing data to the server. So that's what they're trying to explain here on the left hand side. So you have the FTP server, you have a network in between the client and the server, and the client have the FTP client installed, and it uses the control connection. And the client opens the first connection to the server for the control traffic, and then once the data connection is established, the clients open the second connection for the data traffic. So that's what it is explained. So port 21 is that control right here happening at the very beginning when the clients connect to the server. And the port 20 is the data connection that is created to transfer data between the client and the server. Server Message Block, or SMB, is a client-server request-response file sharing protocol. servers can make their own resources available to clients on the network. There are 3 functions of server message block or SMB messages. They are start, authenticate, and terminate sessions, control file and printer access, and allow an application to send or receive messages to or from another device. Unlike the file sharing supported by FTP, clients establish a long-term connection to the servers. After the connection is established, the user of the client can access the resources on the server as though the resources is local to the client host. So this is a very important concept. Unlike the FTP, where you had to have an FTP client in order to access those files within the FTP server, using SMB, the server message block, what you can do actually, you can create a network folder within your client's computer. And once that network connection is established, once the client establishes a long-term connection using the SMB, the user of that client can access the resources on the server through that connection like that it is a local file. Like for example, if you have a network drive at your office, for example, every single time you log into your computer, when you access that network drive through your Windows computer, that is most likely be using the server message block system. So those are the differences between the FTP and the server message blocks. So server message block clients establish a long-term connection to the server. And that would bring us to the end of this lecture, and I will go over a summary of what we have covered. In this module, we learn application layer protocols are used to exchange data between programs running on the source and destination host. The presentation layer has 3 primary functions: formatting or presenting data, compressing data, and encrypting data for transmission and decrypting data upon receipt. The session layer creates and maintains dialogues between source and destination applications. In the client-server model, the device requesting the information is called a client, while the device responding to the request is called a server. In a peer-to-peer network, 2 or more computers are connected via a network and can share resources without having a dedicated server. So make sure you know the differences between client-server model and peer-to-peer network and how to describe them. 3 common HTTP message types are GET, POST, and PUT, and make sure you know the definitions of those and how they are differ from each other. Email supports 3 separate protocols for operation: SMTP, POP, and IMAP. And again, make sure you know the differences among them, and especially POP and IMAP. DNS protocol matches resource names with the required numeric network address. And remember why we need DNS, because humans are easy. For humans, it is easy to remember sanuja.com or cisco.com as opposed to remembering an IP address for sanuja.com. And that's why what is the primary reason why we have DNS. The DSCP for IPv4 service automates the assignment of IPv4 addresses, subnet masks, gateways, and other IPv4 networking parameters. The DSCP version 6 messages are solicit, advertise, information request, and reply. We did not go over in depth how the DSCP version 6 messages works, but you should know roughly the differences between IPv4 DSCP and the IPv6 DSCP. An FTP client is an application which runs on a computer that is being used to push and pull data. In other words, send data or retrieve data from an FTP client. And remember, FTP client is required on the end device in order for it to access the FTP server. 3 functions of SMB messages are start, authenticate, and terminate sessions, control file and printer access, and allow application to send or receive messages to or from another device. You should also remember that compared to FTP, SMB creates long-term connections with your end client, and that allow the user that is using SMB to access network drives containing files and folders, like they are accessing that information as a local resource, as opposed to FTP. It's pretty obvious it is a remote resource. So those are like key differences between FTP and SMB you should be remember for your CCNA and CCNP exams. That is the end of this module. If you have any questions or concerns related to this particular module, you are more than welcome to leave a message in the comment section, and I will try to get back to you as soon as possible. Please make sure to thumbs up this video and subscribe to my channel. And until next time, have a nice day and good luck with your exams.